Welcome to our class, everyone. Today, we will talk about how to close a thread. When we close a thread, do we got the zombie thread? If we got zombie thread, how we rebuild? So we will talk about the end of a thread today, okay? So let's look at this example. This example, the main thread created two peer thread here. So it's create two peer thread. And inside each peer thread, there's a different code. And if you see this code, actually there's a difference because right now we will talk about when the thread stop. So let's see the p thread 2 first. P thread 2 use a return. So when p thread 2 finish the code, the function piece for p thread 2 just finish and it's return. It will try to return to the main thread. Actually, it's try to pass some information to a main thread. So actually, in this one is fine. It's totally fine. It's just like a p thread finish and just like pass a value to the main thread. Okay. But another case, if your peer thread one just like do the exit, what happened? The exit means terminate a process. So if your peer thread say exit, you will find that no matter what's the value, what's the instructions the main thread try to do, what's the task the p thread 2 try to do, they will be terminated. So if you use exit, it means you terminate all thread. Why? Because it terminates the process. If one of your thread terminates the process, means every thread inside the process will got like a killed, will got terminated. So exit is not a good function in your thread to define if you want to exit without like a return. If you just want to exit because you see some error message, because you cannot do it anymore, you want to exit, then what should we do? Actually, there's a function, another function called pthread_exit. So we should change this one to pthread_exit. So we will do pthread_exit here. After you call pthread_exit, it's just like a finish. It's try to like return some value into the main function, and let's just finish it. So in this case, just this is a different. The exit terminate all the thread. Pthread_exit terminates the thread itself, one thread, the thread itself. So if you want to terminate the thread, use pthread_exit. Don't use the exit, okay? So here's another question. So if you have a while loop, infinite while loop one here for your main thread, and your pthread2 return to it, your pthread1 exit, pthread_exit to it. So which means they try to tell the your main thread that like, okay, I want to stop. I want to stop. I already stopped. So can I stop? And how you deal with this? In this case, if your main thread doesn't handle it, not just main thread, if you don't have any thread to handle it, then of course you will got some terrible idea. Same as a process. So do we got the zombie thread? The answer is yes. You got the zombie thread here. You got zombie thread if you don't care. If you don't care. Okay? But the thread is different. For process, the parent process need to wait for child process, right? This is for process. But for the thread, no matter which thread you want to use, you can have a main thread, you can have peer one, you can have peer two. You can put wait on your peer one, waiting for a peer two. Still it's working, okay? So even though main thread created both, but you can use one of your thread to wait to read the zombie. So the model is different. Imagine that the process is more like a parent-child, this kind of a hierarchy. But for a thread, everyone is like a friend. The peer is my friend. The peer two is my friend. Everyone is my friend. So if one friend want to leave, want to like go out, any one of my friend can take care of it. Okay, so this is the difference between the process and the thread. In the thread, no matter which one, as long as you have one thread can handle, can wait, it's not a wait, but let's say can wait, can take care of another thread, then it should be fine. Okay, so back a second. So if we got zombie, how we wait? How we create a wait? So inside this thread function, there's a two function you can use to deal with this zombie thread. One is called pthread join. Hey, let's join. You finish, it's fine. Join my group, join my code, join. Another one is pthread detach. Pthread detach is in the thread, it's just try to detach from the group. So you don't need to take care of it because it's the thread's choice. It's your choice. You want to detach from us, so of course you don't need our care. Okay, so let's look at what's the example about the pthread join and pthread detach. So this is the idea how to use pthread join. So pthread join is very simple. We just use pthread join, and for the pthread join, we need to provide a TID. What's the thread you want to wait? Okay. So because it's not a parent child, you definitely need to know which thread you want to wait, you want to read. So in this case, we create the pthread, we create the thread, and we got the TID, and we pass TID here. We use this TID to join, to wait, to read the zombie thread. So this is how to use pthread join. It's very similar to how we use wait or wait PID in our main process, the parent process. But here, there's no parent thread. Every thread is a peer. So you can use the thread in your pthread 2, like the peer 2, to wait for peer 1 by using this join 2. Another one is different. The difference is the another one, the detach is inside your thread function. So for first one, it's inside your main function. The second one is inside your thread function. So the detach, you don't need to like pass the TID. What's the TID you want to read? Because it can read itself. So for the pthread detach, you just say pthread detach, I want to read myself after the end. So it's kind of, okay, this thread just is created, but this thread can do anything independently without communicate to the parent. And the thread just like finish this job and just like detach itself. So it won't become zombie. So this is another way to reaper zombie. Actually, this is not a reaper zombie. This is more like a not create a zombie. Okay, because it's the thread itself is already rip itself. So it's like I won't become zombie. Don't worry about me. Let me go. Then it's just detach. Okay, so this is two function we can use to reaper zombie thread. One is we define a pthread join in one thread to rip another thread. Another one is we define a pthread detach inside the thread itself to detach it from the other thread. So when this thread is going to finish, it won't become the zombie thread. So that's a two function can handle this. Joe, I have a question. Why we need these two different functions to deal with the same situation, the zombie? Or when we want to use detach, when we want to use the join? This is a good question. So when we use pthread join, when we use pthread detach, depends on the purpose. So what's the purpose to use pthread join? If you want to get the return value of your peer thread when it's finished. So for example, the thread finish return some like important value or return some like an argument, some data from the thread passed back to your main thread. We use pthread join because we want to get some information from the thread after it finish. So we use pthread join. You can imagine that the thread just like run a function, right? So if you want to get the return value of this function, how to do it? Use pthread join can help you to get the data from the thread. But if you don't care, if you don't care what's the data, what's the return value, what's the behavior inside the thread, we will suggest you to use pthread detach. Why? Because when you use pthread detach, your pthread, the main thread or other thread don't need to wait. If you try to wait something, say pthread join, you will stop there. You will stop the line until other program finish, other thread finish. So if I run my main thread until this line, the p thread join, it will just stop here until other thread finish, then execute this p thread join, then you will continue to the main thread. So actually, it makes your code slower, especially in server. If your server need to wait for each thread, it's useless. So you need to find a way to not to need to like wait for this thread. Just allow this thread to read itself. If you don't care what the data it will return. So in conclusion, why when we will use pthread detach? If you don't care what's the return value from the thread, use pthread detach. If you want to get some data, some information from the thread to process, then use pthread join to wait for the peer thread. Okay. So let's see this example again. So this example we showed in other videos. We create a thread and we try to bring out something to the thread. We pass an argument to the thread function here, and we use this argument to do something. And actually, we use this argument to compute something. We just change the argument. If we pass a 15, we got 15 plus 1 and we return 16. So we just add 1 to this argument and return it. So in this case, we need the pthread join. So because we want to get the value of a return value for it, so we use pthread join. So how to use pthread join? We say, okay, I give you a TID. What's the peer ID of this thread? Then I use a special variable called return value. This return value can help us to store the the value. So we define an integer value, return value, and we pass the address to it because we still need to cascade it, right? Because the function return a void star. So we return it, then we try to store the value into this return variable, and after that we can try to print out a return value. Okay, so this is the source code, and we can do GCC again. We need to dash pthread to create it. Then we still got the warning message, but we can ignore it because we are sure this casting is correct. Then let's try to run something. So we pass 4. So you should return 5. So after 1 second, you can see the return value of a peer thread is 5. So you got the return value from the peer thread by using the pthread join. Pthread join can support this part. If you want to get the data from other thread, use pthread join. Okay, so we can try another number. We use 10, then it's return 11. So it works. It works in this situation. Okay. So another one is that if you don't want to do a pthread join, you don't care the return value, you can remove it. And of course, in this case, to avoid to create a zombie thread, you should say pthread detach here. And pthread detach should detach the itself. So we will say pthread self. So we use this to remove itself. So let's see how it look like. Okay, we still do GCC. Then we still run the thread hello and give a number. So you can see it's successfully finished. So still, it won't create any zombie thread because you use detach to detach itself from the thread group. Okay, so this is the idea. So I hope you enjoyed today's videos. Today we talk about how to terminate a thread. Actually, there's a couple ways. If you use exit, it will terminate all the thread. If you just use the pthread exit or return your peer thread, then it's fine. It's just try to send some message back to the main thread. And you can use pthread join to get this message. Of course, if you use pthread join, you can like rip the zombie. You can avoid to create a zombie. Okay, and if you don't want to use pthread join because you are running a server and the server should not wait for each like any single thread, so of course you can use pthread detach in this thread. The pthread detach inside the peer thread can get rid of its like from the group of your thread group. So you don't need to take care of the thread when it's finished. So which means you won't get any zombie thread in this case. Okay. So I hope you enjoyed today's video and got like a more like a understanding on this pthread interface. And see you next time. Next time we will talk about the sharing a little bit more. And I hope you can get the sense how to do a sharing with this thread, makes it more powerful, or even it's dangerous, but it still makes it powerful. Okay, so we will talk about sharing in other videos. So okay, so this is for today. See you next time. See you in our next videos. The pthread join pthread detach this zombie ripping stuff is awesome.